Welcome back to Database Internals Crashcasts. I'm Sheila, and as always, I'm here with my co-host, Victor. Before we dive into today's topic, I want to remind our amazing listeners that if you're enjoying our show, please take a moment to rate us on your favorite podcast platform. Your support means the world to us.
Absolutely, Sheila. And hello, everyone. We're excited to continue our journey through the Relational Database Systems season. Today, we're diving deeper into the Relational Model Concepts chapter, specifically focusing on keys and constraints.
That's right, Victor. And to kick things off, I've got a brain teaser for our listeners. Here's the quiz question. In a university database, a student can enroll in multiple courses, and each course can have multiple students. What type of key would you use to uniquely identify the relationship between a student and a course, and why?
Ooh, that's a great question, Sheila. It really makes you think about the nature of relationships in databases. Without giving away the answer, I'd say this question touches on some fundamental concepts of database design and how we ensure data integrity in complex scenarios. Listeners, keep this question in mind as we go through today's topic. The answer might surprise you.
Excellent, Victor. Now, before we dive deeper, let's quickly recap some key terms. We've talked about relations, which are essentially tables in a relational database. Tuples are the rows in these tables, and attributes are the columns. Is that a fair summary, Victor?
Spot on, Sheila. Those are indeed the building blocks of relational databases. Now let's start exploring keys and constraints. Sheila, what's your understanding of these concepts?
Well, from what I gather, keys and constraints are like the rules and identifiers in a database. Keys help us uniquely identify records, while constraints ensure that the data follows certain rules. Am I on the right track, Victor?
You've got the essence of it, Sheila. Let me expand on that a bit. Keys are indeed used for identification, but they also play a crucial role in establishing relationships between tables. Constraints, on the other hand, are rules that maintain the integrity and consistency of the data. They're like the guardrails that keep our data clean and reliable.
That makes sense. So, can you tell us more about the different types of keys? I've heard terms like primary key and foreign key thrown around.
Absolutely. Let's start with the primary key. It's a special type of key that uniquely identifies each record in a table. Think of it as a social security number for your data. No two records can have the same primary key. Foreign keys, on the other hand, are used to create relationships between tables. They reference the primary key of another table, establishing a link between the two.
Oh, I see. So if we had a students table and a courses table, the student ID in the courses table could be a foreign key referencing the primary key in the students table.
Exactly right, Sheila. That's a perfect example. There are also other types of keys, like candidate keys and superkeys. A candidate key is an attribute or set of attributes that could potentially serve as a primary key. A superkey is any set of attributes that can uniquely identify a record, even if it includes extra, unnecessary attributes.
Fascinating. Now, what about constraints? You mentioned they're like guardrails for our data. Can you elaborate on that?
Of course, constraints are rules we define to maintain data integrity. There are several types, but let's focus on three main ones: domain constraints, entity integrity constraints, and referential integrity constraints. Domain constraints specify the allowable values for an attribute. For instance, you might constrain an age field to only accept positive integers.
That makes sense. It's like setting boundaries for what kind of data can go into each column, right?
Exactly. Now, entity integrity constraints ensure that each record in a table is uniquely identifiable. The primary key constraint is an example of this. It ensures that the primary key is always unique and not null. Lastly, referential integrity constraints maintain consistency between related tables. They ensure that foreign key values always refer to an existing primary key in the reference table.
I can see how these constraints would be crucial in maintaining data quality. But Victor, I'm curious. How do these concepts translate to real-world database design?
Great question, Sheila. In the real world, proper use of keys and constraints is fundamental to creating robust and efficient databases. For example, in an e-commerce system, you'd use primary keys to uniquely identify products, orders, and customers. Foreign keys would link orders to customers and products. Constraints would ensure that product prices are never negative, that each order is associated with a valid customer, and that you can't delete a product that's referenced in an existing order.
That's really helpful, Victor. It's like keys and constraints work together to create a well-organized, reliable database ecosystem. Are there any common pitfalls or misconceptions people should be aware of when working with these concepts?
Absolutely, Sheila. One common misconception is that you always need to use auto-incrementing integers for primary keys. While this is often a good choice, it's not always the best option. Sometimes, natural keys, existing attributes that can uniquely identify a record, can be more appropriate. Another pitfall is overusing constraints. While constraints are crucial for data integrity, too many can impact performance and make data modifications more complex. It's about finding the right balance.
That's really insightful, Victor. It sounds like there's quite an art to designing databases effectively. Do you have any tips or best practices for our listeners who might be working on database design?
Certainly. Here are a few key tips. Point 1. Always define a primary key for each table. 2. Use foreign keys to enforce relationships between tables. 3. Apply constraints judiciously. Use them to enforce business rules, but be mindful of performance impacts. 4. Consider the future. Design your keys and constraints with potential data growth and changes in mind. 5. Document your keys and constraints thoroughly. Future you or your colleagues will thank you.
Those are great tips, Victor. Now, before we wrap up, I think it's time to reveal the answer to our quiz question. Remember, we asked what type of key would uniquely identify the relationship between a student and a course in a university database. Victor, would you like to do the honors?
I'd be happy to, Sheila. The answer is a composite key. In this scenario, we'd use a combination of the student ID and the course ID to uniquely identify each enrollment. This composite key would serve as the primary key in an enrollments table, creating a many-to-many relationship between students and courses.
That's brilliant, Victor. It really illustrates how keys can be used to model complex relationships in databases. To sum up today's episode, we've learned about the crucial role of keys and constraints in relational databases. We've explored different types of keys like primary keys, foreign keys, and composite keys, as well as various constraints that help maintain data integrity. We've also discussed real-world applications and best practices for implementing these concepts.
Excellent summary, Sheila. I hope our listeners found this deep dive into keys and constraints helpful. Remember, these concepts are fundamental to good database design and will serve you well in your database journey.
Absolutely, Victor. And to our wonderful listeners, thank you for tuning in to another episode of Database Internals Crashcasts. If you enjoyed this episode, please visit crashcasts.com, join our Discord community, or support us on Patreon. Your engagement really helps us keep creating this content. Until next time, keep those queries optimized and your data integrity strong.